Hello friends, today we are going to learn the second most important sections in any laptop. These sections generate a 3 volt and 5 volt. In last video we learned adapter input and battery charging section. In that video we saw how adapter voltage is passed to MOSFET and come across the current sensing resistor, and then this voltage spread entire motherboard. In the motherboard there are various buck converters are there which generate different voltages. I already told you in laptops there are so many chips and each chips require different voltages like 1.5, 1.05, CPU core, graphics core, 3.35. In laptop there are varieties of voltages are required to work, but in that there is a one voltage is very much important, is that 3 volt. This 3 volt it goes to the SIO, and in any laptop the first component which is going to on is a SIO, and SIO need a 3 volt. So after giving the power to the laptop either on the battery or from the adapter, the SIO get the power, just like our heart. When we sleep, at that time our heartbeat is running. So similarly, when the power is there either with the adapter or from the battery, SIO get the power, and that power is 3 volt. So in these sections we are going to learn how this 3 volt is generated. So in the screen you can see this concept diagram. I'll explain you how this concept is work, and then we'll go to the schematic diagram. Okay, so let's start. So the first I'll introduce you these chips. This chip is a TPS 51125. It normally this 3 volt and 5 volt sections have varieties of chips like TPS 51125, TPS 51123, RT8205, RT8203. There are varieties of chips are there, but the concept remain the same. There is no difference in the concept. So the important thing is you have to understand the concept. Okay, so let's start. So this chip is a TPS 51125. In sometime they use a RT8205. Now why this written as CJ is equal to DA, that I'll explain you. The size of this chip is so small. The size of the chip is so small, so that is why it's not possible to print the entire number on the chips. So that is why the manufacturer use the code. So from that code you can come to know the chip number. So here is a chip number is a C0. The C0 means the chip number is RT8205. So like that. So whenever nowadays in a laptop motherboard you won't find a chip entire chip number. There is only a 2-digit code. From that 2-digit code you will come to know that the chip number. In our books all chips codes are given, so you can refer our books also. So let's start. So first, now the chips have a total 4 departments, the 2 linear outputs and 2 buck converters. The linear output means the simple is that whenever we apply a voltage, suppose we are applying here 18 voltage, at that time linear voltage generate some output voltage. So in these chips there are 2 linear regulator. One is for the 3 volt and another is for the 5 volt. The 3 volt linear regulator generate this 3 volt. The pin name is called a VRG3. The VRG3 or LDO03. VRG3 generate a 3 volt, and here is a VRG5 generate a 5 volt. So whenever you see this pin VRG3 or VRG5, you should get here a 3 volt. So just remember this point. This point is very important. So let's begin. Now when we apply the power it goes to the chip VIN pin. Now the VIN pin got the power. The VIN pin got the power, that is 18 volt. As soon as the VIN pin got the power 18 volt, immediately this chips release the two voltages, that is 3 volt and a 5 volt. It's called the linear voltage. That is VRG3 pin and VRG5 pin. 3 volt and 5 volt is output. Now if this 3 volt and 5 volt if not coming from the chip, that means either this chip may be faulty or some output is loading to the power. So you have to check that. So you must remember this point. This point is very important. So the step number 1, we mention here the steps also. You so follow the steps. The first step is VIN pin should get a 18 volt. Step 2 is VRG3 pin will get a 3 volt and VRG5 pin will get a 5 volt linear output. Now I already told you this chip have a total 4 department, 2 linear regulator and 2 buck converter. Now the linear regulator is turned on, then don't need any enable signal for this chip. But buck converter require a enable signal. Without enable signal they can't work, and every enable signal require a 3 volt. So in the buck converter concept there is an enable as well as there is a power good. Enable is an input signal and power good is output signal. So this 3 volt out, and normally this 3 volt going to the SIO. So SIO get the power, and as soon as we press the power button, SIO release a enable signal, that is a 3 volt. SIO send this 3 volt enable signal to these chips. So once these chips get the enable signal from the SIO, he started triggering this 2 MOSFET. Here are 2 MOSFET and here are 2 MOSFET. So there are total 4 MOSFETs are there on the both the side. Now this 2 MOSFET started triggering, and here is a coil. This is a concept of buck converter. If you don't know how to buck converter works, then you can watch our another video about the buck converters. Okay, so as soon as these chips get the enable signal, he started a triggering. UG means the upper gate, LG means the lower gate. He started triggering, and then the 3 volt and the 5 volt will be generated. Here 3 volt always, and here the 5 volt always will be generated. This 3 volt is a linear output. This power normally goes to the SIO, and this 3 volt as a buck converter output, and normally this power generated after power on, this voltage generate before the power on. So this is the main difference, and this will give the more current, like more than 10 ampere, and here this linear regulator generate a few milliampere current which require to run the SIO. So it's like that. So you must remember this point. Now the next is, once he generate this 3 volt here and 5 volt here, that is the step number 6. That means my entire section is working perfectly. Then this chips release one signal. That signal is called the power good signal. The power good signal is also a 3 volt. So this chip will release a 3 volt signal, is called the power good. Step number 7. So power good signal means the entire section is working fine. So my dear friends, so in this way this sections work. This is a very important section. This section, step number 2. So first video, that is adapter input and battery charging sections, and this second video, it's called always voltage section, which generate a 3 volt and 5 volt section. So whenever you have a dead laptop, you have to test this sections. So now we'll see in the schematic diagram how we can trace this signal and which are the test point. We open a diagram, that is a Compal LA7901, and we are going to see is 3 volt and 5 volt section. The model is Compal LA7901. Now we'll open a 3 volt and 5 volt section. The 3 volt and 5 volt section is normally on the last page, last few pages. So we'll scroll pages like this. So this is a 3 volt and 5 volt sections. So I'll zoom it. We'll see, I'll show you how this thing works. So this is a page number 45, and this chip is PU100. This chip is PU100. This is a location number, and the chip number is RT8205. This is a 24 pin chips. RT8205 is a real Richtech chips. Okay, the manufacturer is Richtech. Now how we test this section? So first we have to locate a VIN pin. This is a 24 pin, and each pin have a specific meaning and specific purpose. So first we have to find where is a VIN pin. So VIN pin is pin number 16. This one is my VIN pin. This one, pin number 16. So here I should get a 18 volt. So you have to check here 18 volt. If the 18 volt not coming here, then that means the problem something is battery charging section. You have to go at the current sensing register and you have to check their voltage. Now if the voltage is coming at pin number 16, then the next thing you have to check is VRG3 and VRG5 pin. So now we'll find where is the VRG3 and VRG5 pin. So this is my VRG3 pin. This is a VRG3 pin number 8. So here I should get a 3 volt, and this one is my VRG5. Here I should get a 5 volt. So you have to test here two voltages. At pin number 8 it should get a 3 volt, and pin number 17 it should get a 5 volt. Now if this both voltages or one of the voltages is not coming, then the possibility could be either this chip may be faulty, that is one, or something loading, something output side, someone loading to the power. So you have to check the resistance with respect to ground. So like that. So now if we imagine if the both voltages are coming, then now to work this buck converter, this chips need a enable signal. So enable signal is this one, pin number 13. So pin number 13 is enable pin, and here we should measure a 3 volt. So at pin number 13, when this chips get a 3 volt, he started triggering, generate the pulses, triggering 2 MOSFET on the both the side. I'll show you where are these 2 MOSFETs. So these are the 2 MOSFET, this side and this side. This side generate a 5 volt always, and this side is a 3.3 volt always. Okay, so once this chips get an enable signal, he started triggering to these 2 MOSFETs from U gate and L gate. So this is pin number 10, You can see in this here pin number 10 is a U gate triggering this MOSFET as pin number 4 of that MOSFET, and pin number 12 is a L gate triggering the lower MOSFET. This is the upper MOSFET and this one is the lower MOSFET. We started generate a pulses like this, and here at the drain 18 volt is there, and when this pulsating AC voltage generated across two MOSFET and this pulsating AC voltage passed to this coil location is a PL101, and then this DC voltage gather across this PC110 capacitor and smooth DC volt pass output. So it's like that. At this point also, this is a upper MOSFET, this is a lower MOSFET, both MOSFETs are there. Started triggering by from pin number 21 upper gate, and from lower gate this side 18 volt is here, started triggering, pulsating AC voltage generated here, pass through the coil at PL103, gather across the capacitor and generate 5 volt here. So in this way, so we can check a 5 volt at this coil or the capacitor, and 3 volt here at this coil or the capacitor. So after finishing this, once this sections is working, then this chips generate a power good signal. So power good is a 3 volt output which the chip generate. After getting enable, he started triggering two MOSFET, 3 volt and 5 volt will generate, and then at pin number 23, you can see here pin number 23, this is called the P good, that means the power good. So this 3 volt is generated, a 3 volt, that is a power good signal. And here at pin number 23, 3 volt is coming, that means my entire section is working. So the friend, this 3 volt and 5 volt sections working like this. So whenever you have a problem, or if the 3 volt and 5 volt section is not working properly, then you have to follow these steps and you have to diagnose in this method. So thank you very much.